In this tutorial, I'm going to talk about properties of acids and bases, also known as operational definitions, how they operate, what they do. The first sort of attribute or their character is change of color of indicators. Now, indicators are organic acids and bases that have usually distinct colors in different hydrogen concentration of solutions. If you are in acidic solution, if you have lots of hydrogen, for example, one indicator that you're used to is litmus paper. Litmus paper becomes red in acids, and you can remember the D of red and D of the acid, so red in acids. And also it changes color into blue when it's in a base. And B of a blue color and B of a base, they go next to each other. So litmus is one indicator that its color changes according to amount of hydrogen you have, or acidic or basic solution. The other indicator is phenolphthalein. You probably have used this also. It's colorless in acidic solutions, and it's pink or purple in basic solutions. So two indicators that you can remember their specific colors in acid versus bases are litmus and phenolphthalein, and that's one property of acids and bases. The second category of properties, I go after reactions. Acids, for example, react with active metals. So acids react with active metals, and I'm going to tell you what are active metals, to produce salt and hydrogen gas. And hydrogen is diatomic, so I write it as H2 gas. Now, active metals they have an acronym. You can remember MAZIT. Now, M in MAZIT is magnesium. It's an active metal. A is aluminum. Z is zinc. I is for iron, Fe. And T is for tin, which is Sn. Now, if you take an acid such as HCl, it will react with magnesium, gives you salt, magnesium chloride, MgCl2, and releases hydrogen gas. Aqueous, magnesium is solid, HCl is aqueous, and put 2 as coefficient. If you take another strong acid such as sulfuric acid, H2SO4, aqueous, let it react with aluminum, for example, another active metal, it will give you salt of aluminum sulfate, and it will release hydrogen gas. And 2 aluminum. So this is 2 examples that you can rewrite it again, and you can remember acids react. That's one of their properties with metals, and they produce salt and hydrogen gas. The second reactions of acids is the reactions, and I call it B category. Acids react with carbonates. Or carbonated rocks to produce salt, water, H2O, and carbon dioxide, CO2 gas. Now, this reaction is known as effervescent. It produces bubbles of gas that are visible. Bubbles of gas. CO2 comes up and you can see it. For example, if you take hydrochloric acid, HCl, let it react with calcium carbonate. Calcium carbonate could be seashell, eggshell, marble, many things. Bones are made out of calcium carbonate, and it will give you salt of calcium chloride. It releases water, and it produces carbon dioxide gas. And we put a 2 for HCl, and the reaction is balanced. If you take ethanoic acid or vinegar, if you remember middle school volcano that some of you made, the last hydrogen of vinegar is loosely held. It's also known as ethanoic acid. If you let it react with baking soda, which is nothing but sodium hydrogen carbonate, it will give you a salt first, which is sodium ethanoate, CH3COO, replace the hydrogen with sodium. It will give you H2O, and it will release CO2, the gas, and you usually had food coloring, and the color of volcano was exaggerated. The very last reactions of acids is they neutralize bases. So acids react with bases, and they produce salt and water. This is known as neutralization, and the process is known as titration. Take your sodium hydroxide, which is a base, add it to hydrochloric acid, you produce sodium chloride plus H2O. Now, some reactions are not easy, like take HCl plus ammonia. So hydrochloric acid, ammonia is a base. It will give you a salt, which is ammonium chloride, NH4Cl, aqueous. Many of my students try to put H2O and they get very confused. So this is one typical reaction, that H2O is body of aqueous. Many times ammonia, when it's dissolved in water, it's written as ammonium hydroxide, NH4OH. These two reactions are exactly the same, and this time you produce NH4Cl plus H2O. So the first reaction is totally fine. It's still neutralization. I really don't need H2O. It's within aqueous. But the second reaction, if you're comfortable with this, also remember it. But be able to deal with both of them depending on the situation and the questions that you're being challenged. Ammonia could be gas, you can pump it into this, or it could also be in aqueous form. So operations or physical properties of acids and bases, change of color of indicators, and typical reactions.